All right, so we are here again to look at odd functions. We looked at even functions. This time we are looking at another type of function. Okay, yes, so this is one of the types of functions. What is what we call odd functions. All right, good. So in this lesson we are saying that odd functions are it's a function where its graph rotates symmetrical about the origin. In the previous lesson, I already explained what we mean by when we say symmetrical. We learned in our previous lesson that even functions when the graph is symmetrical about the y-axis. That is, I explained what we meant by when it is symmetrical about what y-axis. Okay, we said that if you try to fold it along the y-axis, it's going to divide it into two equal parts, and each part can fit onto the other part. Okay, so the same thing applies here, but this time we are seeing about the origin. We know that the origin is the center here, so when it can rotate, when you rotate it, or maybe you try to fold it along the y-axis or the x-axis, each part can fit onto the other part equally. All right, good. So that is what we mean by when we say symmetrical. It divides it into two equal parts and can fit onto another part or each other. All right, good. So as the name suggests, odd functions. So example, so you're looking at this graph, you see this is what a graph of an odd function. This is what x cubed. So all the polynomials, all the polynomials or polynomial functions having what the degree of what, when the degree is odd, they are all examples of what odd functions. So we can talk about x, okay, with degree 1, because 1 is what odd. You can talk about exponent 3. What again? You can talk of 5. Once you realize that the exponents are odd, as the name suggests, odd functions, they are all examples. We can also talk about the sine function. Okay, yes, sine functions. All these are examples. We can talk about a lot. Sine and its inverse, they are all what odd functions. So some of these are examples that we can talk about. All right, great, good. So as we did in our previous lesson, we tested or proved how a function is even, or we shown how or you can see, or you can prove that a function is even. This time we are going to do same here. We are going to show whether a function is an odd. All right, good. So we are going to do that. So if that is the case, algebraically we are saying that if a function, so we can say that a function is odd if and only if and only if f at negative x is equal to negative f at x, or we can also say it is even if f at x is equal to negative f at negative x. So we can also use this to test whether a function is what odd. Okay, so the same approach we used in finding out whether a function is an even, we are going to use the same approach, but this time odd functions, they have their own way of doing that. Okay, we are saying that if f at negative x is the same as negative f at x, or if f at x is equal to negative f at negative x, then we can conclude that that function is what? Odd. So without wasting much time, let's take examples and see how we can test them. All right, great. All right, so let's look at these two examples and see how we can check. Okay, so you have been given these two ways of doing that. We can use the first one or the second one. Okay, but in our case, I'm going to use the second one, where we have f at x is equal to this, because already the question is give us what? F at x. So we already know f at x as this. Okay, so I'm going to use the second one. Okay, doesn't mean you can't use the first one. The first one, the reason why I'm not using that one, because you need to work for this one and at the same time work for this one. But in the second one, we are only going to work for this to save our time, because this is given in the question. All right, good. So if I'm going to use the second one, then we are saying that for a function to be odd, f at x should be equal to negative f at negative x. Okay, good. So I'm going to compare this one here. I will write it here like this, minus 4x, which should be equal to, so I'm going to put this here. So the negative will come, because it said I should negate the whole function when I substitute negative x. Okay, so this is what is going to happen. Now the negative is here, so it said I should put negative x wherever I see x. So I'm going to do that. 2x, okay, minus open bracket, so minus x, and they said I should take cube of that. Okay, all right, so minus my 4 at the same time what? Negative x. All right, so that is what we are going to test. Okay, good. Now let's still keep this one and work things out here. Now we know that whenever you take a cubic exponent of a negative, it still gives you negative. It is like saying negative x times negative x times another negative x 3 times, because it is cube. Okay, we know that negative x times negative x gives us what? Positive x squared, times we have this negative x. Okay, so if I'm multiplying this times this, then the negative one is positive, one is negative. The negative will affect this one, which will give me negative x cube. So one trick I will show you is that anytime you are the exponent, okay, anytime the exponent is odd, then the thing, if it is negative, then it will still be negative. For instance, if you have negative x exponent 1, negative x exponent 3, negative x exponent 5, and the likes, the moment you realize that the exponent, they are all odd, know that your answers are still going to be negative. But if your exponents are even, know that your answers are going to be positive. So note this. All right, great. So once we realize that this is what? Odd, then we are going to get negative 2x cubed. Then this is negative, so negative will be positive. Okay, yes, so here I must write my negative here. Then we have 4x. Good. So let me open the bracket here. Negative, so we know that this is negative 1 times this. If I open the bracket, this is negative, this is negative, so I'm getting positive 2x cubed. This is negative, this is positive, so I'm going to get negative 4x. Now let me write the right part and see if they are the same. 4x. Good. So you realize that this and that are the same. Once they are the same, then you can also see that this function is what? Odd function. Okay, odd function. So we have tested this one and have realized that we have gotten the answer. But before you forget, let me remind you on this. Now, the fact that if you test for a function, if you test for even and odd and none of them, if you test for odd function and it is not odd, it doesn't mean the function is even. Take note of that. The same way, if you test for even function and it is not even function, then it means that that function is also odd function. No, there are times that you may test for all of them, which all of them may not be what even function. In that case, we have other cases, so we'll do that later. We will talk about that later, but as it stands now, our focus is on what odd and even functions. Okay, all right. So the same way, we can also use a number to test for this. So let me use 2 as we used in our previous lesson. So we can say that when x is equal to 2, so I will just substitute. So this is what I'm going to write. So it's going to be this neg 2. Have you gotten that? That is the definition of the odd function. If that is the case, then I'll put 2 here, which will be 2 cubed minus 4 multiplying 2 is equal to my negative. Then I have my 2 here, multiplying negative 2 cubed minus 4 multiplying negative 2. So we know that 2 cubed gives me 8. So we have 2 here is 8. Let me put it here. Minus this times this gives me what? 8, which is equal to, let me bring my negative. You know that 2 squared is what? It is cube, not squared. And I've already told you that when it is cube, it will still be what? Negative. So I'm going to still have negative what? And what is the cube? 8. Okay. All right. Good. Minus or plus, because this is minus, so it's going to be plus 8. Okay. Great. So this times this gives me 16 minus 8, which is equal to negative. Let me keep the negative again. So this times this gives me negative what? 16 plus 8. Okay, good. Now this minus that gives me what? 8, which is equal to, let me still keep my negative. So negative 16 plus 8 gives me negative 8. So here is equal to, now negative will give me positive 8. So you realize that as we use the number, we have gotten the same. We have proven that it is still what? Odd. Okay. When we say odd, it doesn't mean that your answer you get must be odd number. That's not what we are saying. And it doesn't also mean that your answer you get should be negative. That's not what we are saying. We are saying that once you apply this principle here, if you apply this principle here, then whatever answer you get here should be the same as what is here. That is what we are saying. Okay. All right, great. So let's see if we can solve the second part of the question. Okay, let's solve the second part of the question. Okay, so for the example 2, what I'm going to do is that this time you are going to use a number to test. Okay, because I've already told you that you can also use a number to test. Okay, good. So as we are saying that for a function to be odd, then f at x should be equal to negative f at negative x. Then it is odd. So if I'm going to use a number, so let's say I'm still using the 2. You can use any number you want. Okay, but I prefer using 2. It doesn't matter. There's no uniqueness in using the 2. I prefer using 2. Okay, so let's say when x is equal to 2, then it means that I'm going to use this principle f at 2 should be equal to negative f at negative 2. Okay, so that is what I'm going to substitute for both sides. Okay, so here I'm going to substitute 2 here. I have my 2 cube minus 3, 2 squared minus 4, 2 here plus 4. So we are going to test whether it is going to be equal to, when I substitute negative 2 cube minus 3 negative 2 squared plus minus 4 negative 2 plus 4. Okay, all right, good. So we know that this will give me 8. 8 times 2 gives me what? 16. All right, and then we have this is what? 4. 4 times 3 gives me what? Negative 12. And this gives me negative what? 8 plus 4, which should be equal to, we know that negative 2 cube gives me negative 8 times 2 gives me negative 16. We know that negative 2 squared gives me positive 4 times negative 3 gives me what? Negative 12. And then we know that this times this gives me positive 8 plus 4. Great. So let's add all of them. Now we know that this plus this gives me negative 20. This plus this is what? 20 as well. Okay. So we know that here the entire this portion will be 0. So let's check whether here will also be what? 0. Okay, great. Now this plus this gives me what? 28. Negative 28 plus 8 gives me negative 20 plus 4 gives me what? Negative 16. It gives me what? Negative 16. So you see that this is not equal. Okay, when we tested with the number, that is not equal. Once you realize that what is here is not the same as what is here, then you can conclude that since f at 2, so this therefore shouldn't come, since f at 2 is not equal to negative f at negative 2, then the function, then f at x equals 2x cubed minus 3x squared minus 4x plus 4 is not odd function. Good. So that is all about what? Odd functions and even functions. All right. So this brings us to the end of today's lesson. Okay, good. Now in our next videos, we are going to look at how to state the domain or find the domain of a function. We shall also look at how to find the range. All right. Okay. So see you next time. Bye bye.